Thank you for coming. My name is Maria. I'm a software developer at Scala. And then we're going to talk about how we can run our AWS dependencies locally more easily. But first, let's start with a story. So make sure you're cozy. So once upon a time, there was this very famous developer called Oscar. This is Oscar. And he had to debug this very, very difficult application. It was just this impossible bug. He didn't know where to start. So he thought, what if I just take my application and I run it on my local machine? So let's imagine Oscar has to run application A. But then he realizes that application A has a dependency on AWS, more specifically on DynamoDB, but it also has a dependency on S3. And then, to make it even more complicated, application A has a dependency on another application that has a dependency on DynamoDB itself, and then it has a dependency on Kinesis for some reason, and then this application has a dependency on another application that has a dependency on some other AWS service. At this point, it doesn't really matter which one. And to top it off, they all live in different AWS accounts. I don't ask why Oscar has to do this, but by this point, Oscar's like, what? So what are the steps he would have to take? Well, first of all, he'd have to get credentials for both accounts to make sure he can talk to them. He'll have to create some testing resources if he's not already allowed to use some ones that already exist. So that's a lot of different resources for this specific case. He'd have to create some test data. He'll have to start the applications individually, and given that all the ports align and all the stars align, everything will just work. But let's see if we can make it a bit better for Oscar. I'm going to introduce for that something called Local Stack. So Local Stack is this taste framework for AWS resources. And Local Stack provides an image that we can run on Docker and make it a bit more easy for our application to talk to a local thing instead of the real AWS. So how would that work? Well, first of all, we'll need to have Docker installed and Docker Compose. And we're going to use Docker Compose to spin up the local stack container. And the way you do it, you just specify the image you want, in case you're not familiar with this. And then under environments, you can specify which AWS resources in particular you want to be spun up. Because maybe you don't need all of them. By default, it just spins up everything, and there are quite a few of them. So for this example, let's imagine that we need DynamoDB and S3, and they're going to be exposed to these ports. And then we can use in our Scala application, we can use this plugin, the SPT Docker Compose plugin, where you could you just have to enable it basically, and then in your SPT console you can run Docker Compose up, and that will spin up the container with the local stack image. Or if you just don't want to add a new dependency on your project, you can just run Docker Compose up and it will do the same thing. Cool. So what do we have so far? We have a container running an AWS-like environment. Now we actually need to create some resources. It doesn't have anything on it. So for doing that, what I like to do is I like to look in the CloudFormation file and look at the resources that are defined there. If you haven't used AWS before, the CloudFormation file is like AWS's way of defining all the infrastructure resources, and you can define relationship between them and like security groups and all sorts of stuff. So what I like to do is look through this and like, oh, I need an S3 bucket. So then I can use the, if you look at the bottom of the slide, you can use the AWS CLI tool to create the resources you need. So in this case, this is a very simple example that just creates a bucket with the name config. And the only thing that's different from what you would do if you were to talk to a real AWS is you'll notice that endpoint URL parameter that tells it, instead of trying to connect to the real AWS, connect to the local one we've just created instead. Cool. So now we know how to create resources. What do we have to change in our app? Because we still have to tell our app to use the local AWS. So all you have to do is change the client of it to tell it again to use your localhost entry point. And what you can do here, this is just an example that just talks to the local one, but in the real world you probably want to have some sort of config that says, if you want to connect, if you're like in a dead environment, use this endpoint override. If not, use the normal client. And then underneath is just a very simple example that just writes an object on a S3 bucket. That's pretty basic. You don't have to change anything else. It's just a client. So the last step is actually starting the application, and we're pretty much done. But by this point, Oscar's like, oh, these are so many steps. Can we do it a bit better? So I say we're developers, so we can use code in our advantage. So what I decided to do is write a plugin to do all of this for you, or at least most of it for you. So what you have on one side of the screen is exactly the steps we've talked about so far. And on the other hand is what would happen if you were to use this plugin. So basically, I took these 3 steps and I combine them into one. And then if you take out the things you don't really have to do every time you run an application, like install Docker and Docker Compose, because ideally you have the same laptop every time. And you can take out the code changes. You basically just remove half of the steps. So what would this plugin do, more specifically? So first of all, it will have, well, it does have some parameters you can set, where you can tell it what resources you need to be running in the local stack container. You can specify where you have a CloudFormation file, and that then the plugin will read that CloudFormation file. It will pick up the resources you need. It will transform them into AWS CLI commands and run that against the container. Any CloudFormation substitutions, they will be done as well, so that's quite cool. And it will provide commands for starting this container with everything set up, killing the container, or just print out the commands if you want to play with them yourself. What it doesn't do, at the moment, I've only implemented it for DynamoDB resources, and it only supports CloudFormation YAML files. So what I was going to do now is I'm going to show you how it works. Let's see how I might here. Can you still hear me? Cool. So what I have here is the repo I've been creating with the plugin. So this is a very basic build.spt file. There is respect to plugin, we can ignore that for the moment, and I've also added 2 example projects for you today. The one that doesn't use the plugin, just very quickly, open this. I've created a very detailed README on how to run it, and it's not very nice, I'd say, especially the part where you actually have to create the resources. This very horrible long command just creates the DynamoDB table. And well, it's a very complicated DynamoDB table to be fair. But what I want to show you is this example with plugin project. So if you look in the resources file, it has a very basic CloudFormation file. It has some parameters, with just an app name defined, an environment, and then it defines a DynamoDB table and lower down. It also has an S3 bucket defined. Now, if we look in the build.spt file again, we'll see that for the project that uses the plugin, all we have to do is enable it, we do here, specify the location of the CloudFormation file, which we do here, and then say what services we need local stack to be running. And in my case, because as I mentioned before, we always got around to implementing the DynamoDB part. I'm just going to spin up the DynamoDB. Cool. So let's go to a terminal. I'm going to open SVT, and while that loads, I'm just going to prove our laptop running in Docker. Typing with one hand. So, okay. So in our project, let's go into the example project. And all I have to do is run, the command is local AWS start. And prints out a couple of things. It says, I will only start the dynamic resources because that's what you told me to do. This command is printed out here. This was actually generated from the CloudFormation we just looked at. So that's pretty cool because you don't have to write it manually. And if you look at this, let me just make it bigger. Can everyone see the font? Or do you want to make it bigger? Cool. So because this can get quite long and quite complicated. That's not because that's for you all the substitutions for the names, and it adds all the attribute definitions and the global secondary indexes. So everything is just here. You don't have to do any typing. That's quite nice. And this is the output. So this managed to create successfully a table for you. And it was pulled down. Oh, what I want to show you actually. Make this one bigger. So now if I do Docker PS, now I do have the container running. And we can run the AWS CLI command to list all the tables that we have, and we should have a table now. Let's run this. And we have the table we just created, so that's very cool. So now if I run the application, go back here, number 1. This application is very simple, it doesn't do anything too complicated, it just writes a record and then it reads it back. But it managed to do so that's quite nice. And then if you, some other commands you could run is local AWS CLI commands. So this is just printing other commands in case either you want to rewrite them or you want to tweak them a bit. This can be quite handy. Yeah, and it says S3 is not implemented yet because it found some S3 services in our CloudFormation. And we can also kill the stop. We'll stop the container that we just created. We do yes. Once finished. Come on. Just a bit. There we go. It's gone now. So that's quite nice. I didn't have to write any weird CLI commands. I didn't have to read the CloudFormation myself. In theory, it should already be there. We don't have to do all these manual steps. Because if you do it manually, it takes probably more than, I'd say, 15 minutes. And it's very easy to get something wrong. Cool. So that was short demo for you. Let's go back. So what I'm going to leave you with is I have a few links to all the resources. You have a link to the local stack repo. They have much more detail about all the services they provide and everything. The second one is the link to the repo I've created with the recipe plugin I've been playing with. What I want to say about that is this is something I've been thinking about for a while now. It's just something I had to do a few months back. And I realized running things locally sometimes can be such a pain. And it took me, there's so many dependencies, it took us about 30 minutes to run anything. And I started this plugin thinking, there must be something we can do to make it a bit better. We are developers, we have all the tools we need. Why not try to make it a bit better for ourselves? And I've learned so much in the process. It's just, I've never written an SBT plugin before. I've learned how to test it. I've learned how to, it's published on BitTray, so if you want to play with it, go ahead. I've integrated with Circle CI, so I've done so many things that I've never done before. It's been really fun. So my message for you today is think about the things that take a lot of time and is not really necessary. Is there anything that you have to do every day? It gets very tedious. Is there anything you can do to change that? And you make it better for yourself, you're going to make it better for your team. So if there's one thing you take with you today, please let it be, can I make it better?